This is the second of 3 videos where I'm talking about exponents. First time I talked about multiplying, dividing exponents, and taking powers to powers. This time it's radicals. Next time it's negative exponents. So just to start with, exponents are radicals. So if I say x to the 1/2, what I'm really saying is the square root of x. And like we learned in powers to powers, if I square x to the 1/2, I'll multiply these. So I'll get x to the 2/2 or just x. Same thing works with cube roots. It's cube root of x cubed will equal x to the 1/3 cubed, which would just equal x. So the root and the power will cancel each other out, and that's the most important concept to understand. When you deal with roots, you can split them as long as you're multiplying or dividing. You can't split them if you're adding and subtracting. Kind of treat roots a little like parentheses. So if I have something that says the square root of 4x, I can rewrite this. This is just an intermediate step. I wouldn't necessarily do this unless you were uncomfortable with this concept. As the square root of 4 times the square root of x. That's what I mean by splitting roots. I can resolve the square root of 4 as 2x. Could also be negative 2x. All right. Numerically, you're often asked to simplify, numbers that may not be perfect squares, especially in things like the distance formula. You're looking for the hypotenuse of a right triangle. Very, very occasionally, the radius of a circle using the circle formula. And let's take a look at that. Let's say I have the square root of 45. Now, your job is to pull out things that either multiply together to equal a perfect square. So you pull out a couple 2's or a couple 3's, or find a perfect square in there. Now, 45 is a pretty easy example because you probably know 9 times 5 is 45. 9 is a perfect square. You can pull out a 3, pull out that square root of 9. But let's say you didn't know that. So you could just say, well, 4 plus 5 is 9. Remember, anytime you add digits together and they are a multiple of 3, that number is divisible by 3. So I could say, well, 3 times 15 is 45. And I can break down 15 further. So right now I have square root of 3 times the square root of 15. I could say, well, square root of 3 times square root of 3 times square root of 5. Got 2 of these square roots. It's a lousy 5. Let's try that again. 2 of these 3's. That's, if you really want to think about it this way, square root of 3 squared because I'm multiplying them. That will cancel each other out. And I can say 3 square root of 5. On tougher numbers, it's going to work the same way. If I have let's say I have 120, right? The square root of 120. Well, 10 is the obvious thing to pull out, but let's say you missed the 10, you don't see it. So I can say square root of 2 times the square root of 60 divided 120 by 2. I can do that again, right? 2 square root of 2, 30. Let's pull out another 2. 2, 15. And then at this point, I would probably just go ahead and write these as 2. So I have 2 times the square root of 2 times the square root of 15. I can break that 15 up. 2 times the square root of 2 times 5 times 15. 5 times 3. There's not much I can do about that at this point. So there's no perfect square that will come out of the 30, basically. So I'm going to be left with just this 2, and I just multiply these back together to get back to the square root of 30. To be honest with you, unless you're really comfortable with that, I would just set my calculator output to do that for me automatically. It's not that hard to do. Okay, so in equations, you have to square to get rid of the radical. So if your variable's under a radical, you're going to have to square. Let's look at just a simple example. Let's say we have x minus 4 square root plus 3 is equal to 5. Just making one up off the top of my head. I can only square sides of equations. I can't square just the numbers. So to square a side, it means I have to square everything, and it can get really messy. So I want to make the equation as simple as possible and try to get this radical all by itself on one side. To do that, I'm just going to move that 3 over. I can't split this radical because it's addition and subtraction. Subtract 3 from 5, I get 2. Now I can square both sides to get rid of this radical, and I'm going to get x minus 4 equals 4. Add 4, I'm going to get x equals 8. You can check this too. So if I plug in 8 here, 8 minus 4 is square root of 4. Square root of 4 is 2. I add 3 to it. That equals 5. Very nice. Now let's look at our little ACT example. 2 square root of x minus 4 square root of y squared. This is a binomial. I can't condense this any further. Check out Expounding to review this a little bit. But what I need to do is actually multiply, FOIL these things together. Oops. Lousy radical beginning. So 2 times the root of x times 2 times the root of x. Well, that'll be 4 square root of x squared, x. Outside, minus 8 square root of xy, and I can put that under the same radical. I can combine those roots. Inside will be the same thing. And finally, we're going to have plus 16y squared, 16 square root of y squared, or 16y. And I can combine these middle terms because they have the same variables, x and y, to the same power of 1/2 or square root. So I'll end up with 4x minus 16 xy plus 16y. You will see problems like this on test day. This is also something that gets wrapped into a lot of other problems. This is a really critical skill. And in some ways, this is a problems video, but it's also a skills video. Make sure you learn it. Make sure you're comfortable with it. Check out the third video on negative exponents. It tends to come up. It's also more of a skills video than a problems video. But you got to be solid on your exponents. No way around.